As requested, question number 18 from chapter 6. We have an elevator that speeds up from rest to 10 meters per second in 4 seconds. That should remind you of the formula. Acceleration equals v final minus v initial over change in t, or if you will, you can do dv dt. So our change in velocity is from 0 to 10 in 4 seconds. So that's 2.5 meters per second squared for acceleration. What we're asked to find is the weight of a person. I'm going to represent the person as just a dot before the elevator starts moving, meaning the elevator is in rest, and so is the person. The person at rest has two forces, force of gravity and an identical normal force, which is equal to force of gravity only in the opposite direction. So you have your mg and you force normal. So then if the dude is 60 kilograms, then it's 60 times 9.8, which is 600 minus 125, which is 600 minus 12, 588 newtons. So 588 newtons is the answer to A. B, while the elevator is speeding up. Now that changes. If the elevator is speeding up, that means that now my force of gravity stays the same, but normal force increases. And I know that the elevator is going up because they told me that it's on the ground floor. So we're going to draw force of gravity. I'm going to just duplicate force of gravity and then duplicate and elongate my normal force. So here's your force of gravity again, going down, normal force going up, exceeding force of gravity. The elevator is speeding up, therefore upward force is greater, and upward force is what it is. F normal minus mg should be equal ma. Therefore, Fn is mass times both accelerations added together. So therefore, normal force, which is the weight in this case, is going to be 60 times, since we got the acceleration to be 2.5, then we have 9.8 plus 2.5, 738 newtons. You could have also done it this way. So if you know 588 is your force of gravity, and you also know that 60 times 2.5 is 150, then when you put them together, you got 738 newtons. Basically what I'm saying is force normal is force of gravity plus 60 times 2.5. That's all you had to do. 738 newtons. And then finally, after the elevator reaches its cruising speed is constant speed. It stops accelerating. It's the same as it was before, 588 newtons. Newton's first law reminds us that an object will be moving at a constant velocity, cruising velocity in this case, when forces are balanced.